All right, so more difference quotients. We're going to do another rational equation, our rational function, and we'll work through this pretty quickly. First step, find f of x plus h, and right off the bat, I didn't even pay attention. So I'm going to tell you what, I don't like that that's an h. I'm going to make it an f. And the reason I don't like it's an h is because h appears in my difference quotient. So let's just make that f of x. So I'm going to find, first step, find f of x plus h. F of x plus h is 3 over x gets swapped out for an x plus h. And I have x plus h plus 1. All right, step 2, find the entire numerator. F of x plus h minus f of x. And this one's rational, so we're definitely going to run into, we're going to have two different denominators when we write this out, and we're going to get them together. So f of x plus h is from the last problem, 3 over x plus h plus 1, minus f of x is the original function, which is 3 over x plus 1. All right, there's nothing to be done. I just need a common denominator. And whenever you're dealing with these, your LCD is always going to be the product of the domains, or domains, the denominators. What am I talking about? All right, so that means I'm going to multiply the first x plus h plus 1, I need to multiply that by what? I already have the factor of x plus h plus 1. Now I just need to get that factor of x plus 1 down there. So now that they have the same denominator, if I multiply the bottom by something, I have to multiply the top by something, by that same thing, in order to retain equality. My second fraction has x plus 1 in the denominator. I need x plus 1 times x plus h plus 1. Again, same rule. If I multiply the top and the bottom by the same thing, I'm technically multiplying by 1. So what do I get? I get 3 times x plus 1 minus 3 times x plus h plus 1, all divided by x plus h plus 1 over x plus 1. In the first video, I did that in a few steps. I'm just going to do it all in one now. So what happens when I get that common denominator is the numerators come along, and then if my fractions are separated by an operator, that operator just moves up to the numerator. So this is what I've got. I'm going to distribute the 3's. I'm supposed to do it as follows, and that is 3x plus 3 minus 3x minus 3h minus 1. This is all still over x plus h plus 1 over x plus 1. And combine like terms in the numerator. 3x minus 3x is 0. Uh-oh, I made a mess up. What did I do? Forgot to distribute that 3 all the way. I sat there and talked about it, and then I didn't even do it right. That was a plus 1, so this should be a minus 3. How did I know I'd made a mistake there? I knew I made a mistake because whenever we do these problems, that second step is always going to lead us to an answer where the numerator has an h in it. Okay, because the end goal is to be able to divide, get rid of the h that appears in the denominator from the difference quotient. So that's what we expect. And then step 3, find the difference, and I'm just going to shorten it to difference quotient Dairy Queen. Here, the difference quotient is f of x plus h minus f of x, all divided by h. F of x plus h minus f of x is what I just wrote in the last one. So that is negative 3h divided by x plus h plus 1 times x plus 1, all divided by h. And we said anytime I've got that, I've got a numerator that has a fraction in it, so my denominator also has a fraction that just happens to be h is the only thing down there, so we say that's h over 1, and we do copy, change, flip, or we say that division is the same thing as multiplication by the reciprocal times 1 over h. H is divide, and I now have negative 3 over x plus h plus 1 times x plus 1. Can I plug in 0 for h and not divide by 0? Yep, that means I'm done.